Hello students, in this video we're going to be talking about the exterior angle theorem. This is the third lesson in the second unit. The second unit talks about triangles and the theorems that we use for them, and the exterior angle theorem is another theorem that helps us find missing angles by using the sum of other angles. Let's take a look at the learning target. Learning target says that we are going to be able to apply the exterior angle theorem. So in other words, we're going to use the exterior angle theorem to solve problems. Using my prior knowledge of the interior angle theorem, we're going to be using what we learned about yesterday in order to fuel what we're talking about today. In the do now, it gives us a situation wherein it talks about an isosceles triangle, and it gives us some of the information of the base angles. Try to use a well-drawn diagram to answer this question. Pause the video and then come back to see if you got it right. All right, in the first step of this problem, you can see that we labeled the 4x plus 20 and the 2x down here as one of the base angles, keeping in mind that when it talks about a base angle of an isosceles triangle, the base angles are the two angles that are congruent to each other, and we also know that the vertex angle is the non-congruent angle. In other words, the angle that's basically on top, right? Since we know that this is an isosceles triangle with two congruent sides and two congruent angles, we can say that this 2x and this 2x are going to be congruent to each other. The base angles are always congruent in an isosceles triangle. Now we can say that these three angles all together add up to 180 degrees. In our next step, we used that triangle sum theorem to say these three angles are equal to 180. We added all of the angles together and combined like terms. Then we solved for x. But keep in mind, the question is asking us to find the measure of all three angles of triangle ABC. So what we're going to have to do is take that x value and substitute it in. And as you can see, we have 4 times 20 plus 20 is equal to 100, 2 times 20 is equal to 40, and 2 times 20 is equal to 40 on the other side as well. Now keep in mind that I'm not done with this problem because I need to represent these in terms of their units, which are, of course, degrees. 100, 40, and 40. No big deal. The lesson today is about the exterior angle theorem, not the interior angle theorem. So the exterior angle theorem in any triangle says that any exterior angle is going to be equal to, when you take the other two interior angles, the remote interior angles, we call them because they're far away from that exterior angle, and we sum them together, we add them together. A quick note on this term of remote interior angles. When we talk about remote interior angles, they're non-adjacent or they're not next to the exterior angle. So if this is the exterior angle that I'm talking about, I'm not going to be using this angle down here. I'm not going to be using angle BAC. I'm going to be using this angle. This is one of the remote interior angles, and this is one of the remote interior angles. Let's label it. And you should think of remote as being far away, like remote instruction is instruction that is far away. These are remote interior angles, which means they are far away from the exterior angle. We cannot use this angle, but we must use this angle and this angle. In this example, you can see, let me scroll this down a bit. In the example that you can see that 35 degrees is this angle and 62 degrees is this angle, it turns out that these two angles, when you add them together, it gives you this angle as well. There's an easy way to prove that, and I'll prove that to you right now. First, let's talk about this situation here. We know this angle is 97 degrees. We don't know this angle, but we know that this is a straight line, which means that this angle here and this angle here, this angle and this angle, are going to combine together to form 180 degrees because they're supplementary angles. The work is on the right-hand side. So we got the fact that this angle, the one with the dot here, is equal to 83 degrees. Let's label that in the triangle here. But of course, there is another way to find out this angle, and that's by using the other two angles in the triangle. This triangle is just like any other triangle in that all three angles equal to 180 degrees. So if I didn't know this 83 degree, let's say I took it out, I could try to figure out that angle just by using the triangle sum theorem, which is 35 degrees plus 62 degrees plus something is equal to 180. That's work is going to be on the left. So notice we get the same answer, which is 83 degrees, so we can label that in as well. With both of these methods, we're getting the same answer, which means that the triangle sum theorem and supplementary angles together can give us this answer. All right, moving on up. In the first model problem, I have two angles in this triangle and I'm missing a third. What I'm going to do is use the exterior angle theorem because these two angles that I'm identifying here are what we called remote interior angles. We call these remote interior angles because they are far away from this exterior angle here. So we can use that information to find out the value of measure of angle LKN. Pause the video and try this one out, and then come back to see if you got it right. All right, and the way that we set up the exterior angle theorem is by writing exterior angle equals interior angle plus interior angle. They're two remote interior angles. So that exterior angle here is angle LKN, K being in the middle because that's the vertex, and that's equal to angle L plus angle M. 70 and 50 together is 120, so this angle out here is 120 degrees. Now there is another way to find this measurement, this 120. If you had used the triangle sum theorem to add 70 and 50 together, you would have gotten 120. And then you could have used that triangle sum theorem to say, well, 120 plus 60 is equal to 180. So you could have found that this angle was 60. And then after that, you could have used the supplementary angle theorem to say, well, 60 plus x is equal to 180, so that this x would be 120. Keep in mind, that's two different steps. The exterior angle theorem saves you a step. It says, if you know these two remote interior angles, you can find the exterior angle. Similarly, you can find interior angles by knowing an exterior angle. Moving on to the second model problem. In this model problem, it gives you the same type of information as the previous problem, but in this case, it is in terms of x, right? These are expressions rather than just numbers. It works the same way. Go ahead and try to use that exterior angle theorem on this problem. All right, you can see that this exterior angle is related to these remote interior angles by the exterior angle theorem. Exterior angle is equal to interior plus interior. We set up that equation and we solved for x. So x is equal to 12. Incidentally, the last question that we had, you could have used the triangle sum theorem to find this angle and then used supplementary angles to find this angle. In this case, you cannot do that. Unfortunately, since these are not numbers, these are expressions, you're unable to find it that way. So you must use this exterior angle theorem. That's why we're teaching it to you. All right, that was the lesson on exterior angle theorem. Remember that the idea is we're taking an exterior angle, any old exterior angle, and it's going to be equal to the two remote interior angles, in this case 1 and 2, not angle 3. The types of questions that you will be faced with are questions that first you need to set up an equation for, and then you need to solve for. All right, good luck studying.